We have two strings, S and T. We have some lowercase letters in S, and we want to find out how many copies of T can we make by using the letters in S. We can rearrange the S, okay? So two copies, yeah? Because look, we have two E's, two R's, two I's, two C's, two R's. Okay, look, two R's here, right? This is two R coming from here, two R, okay? Four R's, okay? And A-N, R-Y-A-N, okay? Yeah? Okay, so we can easily map it. Yeah? So two copies. Okay? How do we solve this problem? What's your thoughts? Eric, Ryan, anybody?
We use counter.
Using counter. What are we using the counter for? We can use the counter in dictionary. Yes, in dictionary. We can use the counter in Python. So what are we counting?
We're counting the amount of
The number of
the
number
letters.
of letters. The number of letters, exactly. Okay, so for example, if we want to construct the T equals Eric, right? For simplicity, ERIC. And then if we use the counter, E will be 1 time, R will be 1 time, I will be 1 time, C will be 1 time. And if we count, we do the same for the counter S. So if the S counter, if E has 2 times, R has 3 times, I has 2 times, C has 3 times. So how many copies can we get?
2.
2, okay. And if R is only 1 time, how many times of copies can we get?
1.
Yeah. Why is that?
Because there's only 1 R, and if it's 2, there's not another R.
Yeah, exactly. So we always aim for the minimum, right? So the minimum, the smallest number of letters, the frequency, determines the number of copies. Exactly. So we can just use the counter. Okay. We can also use the brute force, but brute force is not very straightforward in this case.
Yes.
So basically, how do we brute force? We go through the letters in the T. If this is E, then we remove the E in one copy of E. R, we remove R. I, we remove one I, and etc. If we can finish removing the letters in S after going through the one copy of T, then we have one copy. And we'll keep going. In this way, we can find out the number of copies we can make, okay? The most efficient solution will be using the counter. We're using the counter object, right? Counter, default dictionary, we go through the letters. We can go through the letters by toString, and then we update the frequency. But we can also use the counter, right? So using the counter, that will be easier. So how do we use the counter? S equals counter, bigger S, yeah? T equals counter. So we have these two counter thing, right? So now we just have to find out the minimum, right? So for example, if in T, the E letter has 2 times, and in S, okay, listen, in S.
But what if the target's not in the string?
The target. That's a very good question. When the target is not in a string, yeah.
Yeah.
That's a very good point. So we can't make a copy, any copy. That would be 0, right? So, but that's a very good point. So look, this if E 2 times here, and in S. This is S, yeah, this is S, this is the target. 8 times. So how many copies can we make? If there are 8 times of E in S, anybody? 2 times of E in the target. So how many copies can we make?
4.
Yeah, exactly. Okay, so Ryan, you mentioned about if there's no such in the S. So if this is 0, so how many copies can we make?
0.
Exactly. Yeah. Got it? Okay, so we need to go through the T, and then we find the corresponding counter, and we divide it by it, and then we get the minimum, right? For example, this E is 8 times, okay? And how about R? R if it is 2 times, and then here R is 1 time. So how many copies can we make? Look, in the S, we got 8 times of E and 2 times of R. In the T, we got the 2 times of E and 1 times of R. So how many copies can we make? How many copies?
2.
2 times, exactly. Because look, 2 divided by 1, 2. 8 divided by 2, 4. we get the minimum, right? Yeah, exactly. Okay, so we can just do this. Return mean SI divided by TI. Okay, so we use the double division here, double divide. This is to get the integer part, which is the floor. Look, this floor. 3 divided by 2. So 1.5. Look, this is flooring. Okay, look, this is floor. This is ceiling. Do you still remember? Ceiling, floor, ceiling. If we 1.5, we get a floor that equals to 1. 1.5 ceiling, that will be 2. Yeah? 1.5 here. Look, 1.5 here. Floor, 1. Ceiling, 2. Using this notation, okay? So look, double divide is to actually the same as the flooring. So we want to get a minimum of SI divided by I for I in T dot keys, okay? T dot keys. So we want to go through the letters in T and we find out the corresponding SI divided by TI. We want to get the minimum, okay? That should be the answer. Alternatively, we can do this answer math dot infinity, and then we go through and then we get a copy of each one. So for I in T, right? T, and then answer equals mean answer SI divided by TI. This is also okay. Return answer, okay? So basically this line, this is a one line thing. If you don't want to write this one line, you can use this answer equals math dot infinity, and we go to the key. For I in T dot keys is actually the same as for I in T, okay? If answer equals max SI divided by TI, get the floor part, okay? The size of the string S is N. The size of the string T is M. So basically we need to go through twice. One time here, one time here, okay? So the time complexity is O(n) plus m. The space complexity will be O(n) plus m because we're using the two counters. Yeah, any questions so far? No? What have you learned today? The last question, always.
About how to rearrange characters to make a target string.
Yeah, so we have the two strings, yeah? And then how do we find out? The question is that we have two strings and we want to find out how many copies of T can we make by using the letters in S. Okay, and what's the solution? How many algorithm can you use?
Count and brute force.
Yeah, and how about the brute force? How do we brute force?
You check.
We go to the letters in T, we remove each letter from the S, and then we can see how many copies can we make by removing them.
And then you rub out.
Yeah, exactly. And then by using the counter, we just basically counting the letters in both strings. And the number of copy is determined by SI divided by TI. Right, that's very obvious. The smallest one, right? The smallest. Yeah. Okay, the time space complexity is about O(n) plus m. Okay, that's it for today. Good job. Bye bye.
Bye.
Bye bye.
Bye bye.